I'm Todd Probert from CACI. I run our National Security and Innovative Solutions sector. I've got a bunch of our teammates and partners up here, and we're excited to talk about SIGINT, AI, and EW, where they're heading, and how we can harness them to work against today's and tomorrow's threats. So in the run-up for this panel, I actually had my team and we sat down and I said, how do I start this? So how do we get into this? And one of the guys in the back, said, hey, tell a joke. I said, all right, great. We're at a Navy conference. What do you got from a Navy joke? And one of the guys got up and they gave me a Navy joke. And I said, well, probably can't say that one in public, so we're not going to go there. The next guy got up, said a joke. Yeah, no, can't go there either. And then the young lady got up and told a joke, and it was probably the most offensive of the lot, and we won't go there either. But you guys see us tonight. We've got a happy hour. I've got a whole new slew of Navy jokes to kind of go over with you. But my conclusion is, I can't tell a Navy joke that's appropriate for public consumption. So we're going to start that. That's really my lesson for the week on that. But good jokes. So come talk.
I was active duty Marine Corps for 8 years. I have plenty of Navy jokes.
Well, I had plenty of those. I had Army and Marine Corps and Air Force jokes, and I figured those were too easy for this crowd. So working through it. But no, so let's get going. A little bit about me, right? So I've been at CACI for about a year and a half. I'm fortunate enough to run a really diverse, actually EW, SIGINT, AI, cyber business, and super excited to talk about it. And we've got some of my team up here to kind of go into depth on that. I started my career out as an Intel analyst, and I did about 10 years, everything from working on console to doing hardcore analysis for the IC and for other agencies around the Beltway. More recently, I spent 10 years at Raytheon. I ran one of Raytheon's 4 businesses engineering groups. I had about 10,000 engineers working intelligence type of things for me, everything from software to SIGINT to EW and a lot of space applications as well. And then my latter part of Raytheon, I ran a very large command and control space and intelligence business. So this is very familiar ground for me and very excited to have this conversation and talk a little bit about what our team is up to. So no surprise that the topic of the past year and a half and certainly the past month and a half is what our peer adversaries are doing and what's happening in that space. And I think the one remarkable thing for me is that EW, SIGINT, the just broad RF spectrum has become more of a topic of conversation. And I've spent many a day, and we've had some conversations obviously this week as well. And the EW environment is of grave concern for everybody. What's happening on the red side, but even equally so, what emissions are coming out of blue, and the ability to kind of look at it and prosecute it and understand what you look like, and then understand what you're going to do in the threat environment and how you're going to go work through that. And then the other big kind of telling point of this conference, right? I haven't been here in a couple of years, but if you roll back maybe 10 years ago, you would not see the confluence of vendors and companies here that you do this year, right? So large presence from a software standpoint, large presence from a commercial standpoint, 5G communications driving all of that. And 10 years ago, it would have been really a big hardware show where folks were looking to kind of drive the simple modalities of what a box could go present. So we're going to go talk in good sense there. I'm excited about this team. I do need to point out that we had one late ad. COVID does not fare well on panels as well. So we've dropped we've substituted our Northrop partner out for a CACI partner, but I'm sure Dennis over there is going to handle it aptly. So let's start this off. I think I'm going to let you all introduce yourselves. So can you guys describe your areas of expertise and how it relates to the Navy and the topic that we're talking about today? So Ramon, let's start with you.
Sure. I'm Ramon Acosta. I've been with CACI for over 11 years. Prior to CACI, I held positions of CTO and VP of engineering at various startups working on electronic design automation, systems management for networking, database management systems, so kind of a broad background in a number of technology areas. At CACI, I've been involved with various Navy and ONR R&D projects on DCGSN, Classic Reach, Red Falcon, the C system. And currently I'm specializing in containers, container orchestration, infrastructure as code, and cloud computing for open system architectures for signal processing.
And how does that relate to the Navy's mission?
Well, you know, the Navy, in many of the acquisitions we're seeing these days, is heavily emphasizing open system architectures, the ability to integrate applications, basically best of breed applications from the government, third-party providers, and also heavy use of containers. So all of these topics are very relevant for the the Navy going forward.
Excellent. Thanks, Ramon. So next we're going to move to Dan, and Dan's one of those newcomers to the scene, but Dell's been a fantastic partner and really a game changer when it comes to the compute side and how we put all of the data to information and then take it to a decision point. So Dan, please.
Yeah, absolutely. So I've been with Dell Technologies US Federal for 5 years, and I have over 20 years experience working within the federal sector, to include 8 years as an active duty Marine and 6 years working at the Marine Corps Network Operations and Security Command out of Quantico, Virginia. I did a lot of early design and implementation for the Marine Corps Enterprise Network that supports our deployed forces. And and that's where my experience plays in.
Excellent.
And then just to throw in, since then I've also done extensive work with the NIST Cybersecurity Center of Excellence around several cyber concerns related to hyperconverged infrastructure, 5G, all the future technologies that the Navy needs to go and win.
Awesome. Looking forward to talking about that. Let's go next to Dennis.
Hello, my name is Dennis Giannoni. I work at CACI as a senior systems engineer. I've been with CACI for over 18 years now. I have significant experience with combat systems integration for U.S. Navy ships, including integration with CWIP. I also have development experience with active array, phased arrays, including air missile defense radar, dual band radars. I've also led a team that actually developed the first Navy training simulator that was used for non-Aegis ships, and it was deployed at all the schoolhouses. And currently I'm specializing in virtual reality and augmented reality technologies that are used for the Navy for maintenance training and also for actually doing maintenance on board the ships.
Excellent. Thanks, Dennis. And last but certainly not least, Matt from SNC.
Hi, I'm Matt Johnson. I'm a senior principal software engineer. You're going to have to excuse me for my Minnesota accent, don't you know? So I've been with SNC for about 7 years now. I've been in industry for about 20. I pretty much specialize in what I'm going to call next generation SIGINT and then enabling distributed operations or remoting sensors. So something that I did recently was we took a traditionally manned TechELINT system that has about a 10 gigabit link between it and its operator, on board, and figured out how to remote that to now a remote operator, via beyond line of sight link where we don't have anywhere near 10 gigs. So I've worked on several DCGS programs. I'm a former radio room guy, so ARCs and DAMAs and PRCs. I've written device controllers and operated those sorts of things. And then currently it's ultra wideband signal processing. We make a 16 gigahertz instantaneous stare that's fielded today. We're working on shrinking that. Precision DF. Yeah. So we're starting to dabble in AI/ML.
Excellent. Excellent. So I've got a bunch of prepared questions, but we're going to go through those. But I'd like to make this as much a dialogue. If you see something you want to kind of jump in on, raise your hand. There's a couple of mics in the middle of the room. And then certainly at the end, we'll go to the audience. And I've got a couple of folks out there that I'm going to pick on if I don't get any questions in. So everybody should have a question ready just in case. We'll put you on the hot seat. So we're going to start with EW first, gentlemen. Where do you see the various technologies that support the Navy's EW mission heading in the next 5 years? Matt, why don't we start with you on that one?
Sure. So something that we're doing now, but I'm going to talk about how it kind of carries us into the future. We've embraced software-defined, hardware-enabled. So we are using more commodity or commercially driven technologies, and so we kind of in our SIGINT processing system. So we've realized kind of a common architecture, or I'm going to call it a signals processing ecosystem that's really made up of software-defined radio, high-speed networking, x86 commodity compute, specialized compute in FPGA or system on chip or GPU, some creative RF or flexible, RF matrix and switching, and then depending upon, kind of the environment that we're going into, storage. So you can take that architecture and it scales. So if we have a very small form factor, I put it in a little box, right? If we have a whole room that we can use, we fill up that room with those resources. But it also allows us to ride, so those individual pieces, software-defined radios, high-speed networking, right? When I'd think about just 5 years ago, right, 10 gig was a relatively new thing. Well, now we're using 100 gig NICs, and we're filling the pipes up, right? So, for example, our 16 gigahertz instantaneous stare, we use 400 gig NICs in order to pass all that data. It's a crazy amount. So, and then RF system on chip, right, or just system on chip in general, where I think that's going to carry us, just not seeing what we're doing now and the potential that it's got for the future, it's kind of amazing. The other thing that I'm going to point out, remember, software guy, DevSecOps certified. So DevSecOps is now, it's becoming commonplace, and it really wasn't, that many years ago. And it's enabling us to go so much faster, and now we are building security in rather than frosting it on at the end. And how important is that? And that becoming our standard operating procedure, how we create things, right? It's just something we have to do. And I think in the 5 to 10 years time frame, it's just going to be standard practice instead of these guys do it and those guys do it.
Yeah, no, that's fantastic. And so my big takeaway is software-defined everything and the ability to kind of build to adapt and move stuff into the fleet. Any gentlemen want to add on to that question?
Yeah, I'd like to add on, talk a little bit about augmented reality. A big part of augmented reality is using object recognition. And currently there's limitations with hardware and software for augmented reality. And when you try to use the technologies, and it can't recognize the object because maybe the object's a little bit different. It's a different lighting condition, or there's a cable. There could be cables in front of the object. So what we're using, we're actually at CACI, we're using machine learning to be able to look at an object, be able to recognize there's something that's blocking the object. It could be a cable, or it could be a different angle for the object, and to be able to do the object recognition so you can do your actual maintenance or training and things like that. So machine learning is becoming a big part of a lot of our technologies we're talking about, and actually you're going to hear that throughout our discussions today, that machine learning is a big part of enhancing a lot of things that we do.
Yeah, and I'm going to be obviously speaking from the OEM perspective on some of this stuff, and when you think about it, from our perspective, what we're looking at for 3 key areas: reliability, making stuff smaller so it fits on the ships, right, and all the different places that we need to stick it out in the field, and less power, right? How do we shrink things down and make them more cost-effective from a power perspective, drive down power costs? And what's been interesting is there were a couple of things mentioned here already in this conversation which are key to what I say the wider conversation as we move forward. The commoditization of hardware, right, is critical, because not only does that help us, right, we can build faster systems and make more complex systems and make them easier to deploy, but it also creates almost an arms race with our adversaries, because that commoditized system also gives them access to those same types of tools.
Yep.
Right?
Yep.
So later I'll get into the whole thing of COTS versus GOTS. COTS is absolutely the right way to go, because that's how you get industry-leading capabilities. But you do sacrifice some of the challenge there, because you're now using open standards that everybody else has access to as well. And then the other area I'll touch on is I absolutely agree with Matthew on the security element. Security needs to be a consideration at the beginning of the process versus later. The executive order that came out last year on zero trust and protecting the nation's infrastructure from a cybersecurity perspective, we often, of course, want to think about the warfighter at the tip of the spear and keeping them safe, but we also have to think about commercial industry, and they need to be paralleling their efforts to protect our critical infrastructure. You look at what's going on in the Ukraine right now, we don't know what's going on and where it's going to go, but we do know there are already reports of cyber attacks on the banks and on the military front-facing websites and stuff like that. So figuring out how to get ahead of those things is going to be very interesting.
Good. Hey guys, just a general reminder to get closer to your mics when you're working through it. No, the answer was great. It just people want to hear
I need to get a little
Yeah,
closer
all right.
like that. There we go.
So Ramon, you're in the unenviable position of being cleanup. So I'm going to do you a favor, and I'm going to give you a new question. How
Okay,
about that?
perfect.
I hate that position because everybody else, they brief
steal all the
everything
good
you
stuff,
have, and you're
yeah.
like, oh crap, what do I say?
Oh,
It's
they had
new.
good stuff.
It's all
I'm
They
good
do.
with that.
They good. Well, so let's just piggyback on what they said. So how do we design systems today to be able to take advantage of all those advancements, right? How do we, what can we do to ensure systems that we build today aren't obsolete tomorrow? I think that's right in your sweet spot.
Right. So, adding on to what Matt said, software-defined everything. So really, as you commoditize more and more hardware and you adopt these open standards, now the differentiation is going to be on the software side. So how do you make that possible? I am a huge proponent of using containers for microservices, and that's made our life as developers just a lot easier. We deliver software, our software, other folks' software as containers. They can be integrated and they can result in complete systems. So containers themselves are not the final answer. So I'm going to hand you 25, 30 containers, go ahead and make a system. It's not done yet, right? So that's where container orchestration comes in, and you've probably heard of Kubernetes. So what is that? So, give me those 25, 30 containers. If I need to create a system, there's a number of problems I haven't solved yet. How do I deploy them? How do I create a cluster? Multiple servers running those containers. What does my networking look like? How do I handle storage, scalability, load balancing, upgrades? If I didn't have a container orchestration capability like Kubernetes, guess what? I'm doing that myself. So that's where something like container orchestration comes in. And eventually, and by the way, it's not easy these days. Still, Kubernetes is hard. You have to have expertise to get that to work together. But eventually, that will become easier, and it will ultimately be part of the operating system. You're going to install your operating system, and it'll come with a container infrastructure and container orchestration really built in. So,
Yeah, no, that's exactly right, and I think we're seeing that across the board. Hey, maybe could you expound a little bit on open architectures and kind of our philosophy around those?
Sure. So, open system architectures, it's more than a buzzword. It really relies on use of open standards. On the hardware side, it's going to be things like Vita 49, CMOS and SOSA, which you may have heard about. So various standards and for interfacing to hardware. On the software side, it's going to be things like the Open Container Initiative for standardizing container formats, message buses like ActiveMQ or Kafka. So that's kind of one aspect of open system architectures. Another aspect is really embracing the ability to integrate components from the government or third-party providers. That base platform needs to support that type of integration from the get-go. And this kind of ties back to, again, something Matt Matt talked about with DevSecOps, it really is from the beginning of the pipeline, having that be part of your, that pipeline is building that open system architecture that enables that integration.
Yeah, no, I think that's well said, and again, the conversations of the day are how do we get away from the monolith of yesterday, right? And I'm going to move to you next, Dan, so you're right on. I got a question that ties right into that, but the monolith of yesterday, the software programs that are too big to fail, but take 10 years to go birth, and in 10 years technology changes so fast that you're working through that. So Dan, for you, what's industry doing today to make this future reality? I think Dell's doing some fantastic things there, and interested in your thoughts.
Yeah, absolutely. It's very interesting. Like 10 years ago, working in industry, companies like Dell, like HP and others, we kept our secrets very close to our chest on how we developed our hardware, how we brought our features to the market, because we wanted, of course, competitiveness. You want to keep your stuff better than everybody else's. But the government and their push to open standards and open requirements around that has really forced us in a good way, I think, to understand that we have to collaborate. Because what I would say is the continued growth of the cyber threat, the electronic warfare threat, has raised a new light on what we're really battling against, right? We could take all of the firepower in this room from a electronics warfare perspective and put it together, and it still is dwarfed by the number of bad actors and bad players out there, which means we all need to work together twice as hard to be effective in developing solutions that are going to help protect our nation and protect our interests, right? So what we're doing is, I think Spectral is a great example of that, is working with our competitors in these scenarios to bring forward better standards and say, hey, have you guys thought about doing it this way? Because from a commercial standpoint, in our exposure to the wider market, this is what we're seeing. So we bring our commercial knowledge, which sometimes, as we always know, commercial spends money crazy, and they're what I'd say is they're more accepting of newer technology. We bring that experience over to the federal government, and we can then collaborate to establish new standards that help us stay ahead, like Ramon was talking about, of that, of that curve. And a perfect example is, like I said, we're doing some work with NIST at the Cybersecurity Center of Excellence on 5G security, and we're sharing things now, like with our competitors and stuff up there, that there is no way we would have opened those books 5, 7, 10 years ago.
Interesting.
That's good. One modulation on all that. We're partners.
Yeah,
and you guys have been a fantastic partner in the move to take data to a decision point and put it to action. And I think that's the exciting part of what you said. And the partnership's been interesting because leveraging the great power of commercial technology, but bringing it into a high consequence space.
Yes.
That if you go look at your cell phone and how apps get tested on your cell phone, they're basically crowd tested. Apple fields an 85% solution, and you get 10,000 people or 100,000 people looking at it. They get a whole bunch of changes in it. That doesn't work when you're in the high consequence space. And I think that combination of legacy kind of insiders with commercial players like yourselves are really changing the game and moving it to that next level. So I appreciate everything you said, and figured I had to pick on you just a little bit there. So
glad to.
That's good. hey, Matt, anything to add on that?
So, yeah, Daniel, thank you, because we're riding that wave. So as you guys are pushing, right, FPGAs are getting so much better, and GPUs are getting so much better. And like I said, just even so, there's a system that we make, and we've seen that we can evolve with the technology. So like I was describing, we started with 10 gig networking inside and then outside of the box. Well, we had some advancements that happened in FPGA processing. We incorporated that. Then we needed 40 gig network pipes to be able to push that, right? So now we did that inside of a VPX system. However, guess what? Now we're going to do that using Dell rack mount servers, and yeah. So, and we're using 100, not 40. So that's just kind of a description or an example of how commercial is driving, and we reap the benefit, right? Because we don't have the kind of capital. Well, how are we gonna make 100 gig into 200, right? We kind of rely on industry for that.
Yeah. Which was the limitation of GOTS back in the day,
Right.
when we were like, oh, we're all, because I was there, like, we're going to build it ourselves, everything is special made, and it from a research and development standpoint, it's just not tenable.
Right.
So.
Right.
Good, good. These guys are all mad at me because I'm jumping around on the questions that we told them we were going to ask up front. But keeping them on the hot seat. Let's go to Dennis next, right? So, fantastic moves from a technology standpoint, trying to employ software in different ways, everything from speed to sensors to those kind of things. But let's pivot. What about training, right? This is a big shift for our military, and we're bringing a lot of technology to bear. What about training? As we add these new capabilities in the future, how do we minimize the burden on our warfighters?
Well, like you said, Todd, I mean, these new technologies are becoming overburdening our technicians on board their ships. So we need to make, from number one standpoint, we need to make sure, like at the schoolhouses, when we do before they get to the ships, we need to give them the most effective training we can. And we have so many great technologies now. I mean, using virtual reality and augmented reality and combined with simulators, we can make sure when they actually get to where they need to get on board the ship, there's training much as possible. Okay, so now when they get to the ship, the most important thing is embedded training is a really important topic. In the past, training is always an add-on. You add it on later. Well, if you add on training later, it's never effective. It needs to be part of the system. It needs to be developed as you develop the system. So the important thing is, as you're going through the development, training has to be part of your tactical builds. So when you you actually deliver your tactical build to a ship, there has to be training integrated with that. All the new threats have to be integrated with those tactical builds. So embedded training is an important aspect of that.
Yeah, fair enough. You got something to add, Dan?
Yeah, training and simplification of the capabilities, right? Like, how do you deploy these systems in the simple way as possible? Because every Marine's a warfighter, right? You may have an IT guy standing up there today who's sitting out in the field. Tomorrow, it may be the cook who has to go and man that server, because that's just how the mission works. And when I was in Quantico, I remember writing out instruction sets, literally step by step, which means that training you're talking about and that simplification is part of the security model. You have to be able to use those things effectively. If you type a wrong keystroke or pull a wrong lever, you can't affect the mission. So spot on.
Yeah. Hey, so maybe Ramon, for you, but I'm curious too, AI, machine learning, great buzzwords. I, as a warfighter, can probably get my head around what a missile's going to go do. So a bomb damage assessment or a projection of a kinetic weapon is pretty well known. You can see it. You can see it afterwards. Cyber effects are quite a bit more nuanced. And then when you get into machine learn type of helping from a cognitive standpoint, how do I trust what's going on? What are your thoughts on that?
Well, quite a bit is being done on being able to explain how those machine learning and AI algorithms are actually working, right? How do they reach those conclusions? How do you validate the answer, the algorithms? In systems we're building today, AI and machine learning are being used in a variety of ways, right? For training, for example, for helping direct workflows for operators, for maintenance, and even deeper for signal processing. We're using AI and machine learning to determine signal modulations and signal types. So yes, we need to emphasize how do we validate that those things are working correctly, and it's a difficult problem, but it's required going forward.
Yeah, and I know in many of the systems that you're fielding today with the machine learning that you're bringing to bear, you're building in confidence kind of factors and all that.
That's
Maybe
exactly
talk a little
right.
bit about that.
Yeah, sure. So as you try to better identify a threat based on multiple inputs, so kind of a data fusion problem. So how do you determine what the confidence is in IDing that particular threat? That's something we're also working on at CACI, and another difficult problem that we're going to be working on.
And Todd, that touches on something that you asked us too, like what does the Navy need to focus on, or really the wider DoD in the next 10 years? Data governance. Data governance is going to be critical to having effective AI. Being able to identify where that data came in as soon as possible, classifying it, and being able to build your AI models effectively.
Correct.
There is no lack of abundance of data,
Yeah.
but being able to comb that data and effectively use it to build your AI models is probably the biggest challenge they have today.
Yeah,
Absolutely.
that well said. And there's a whole cottage industry, I think, about to be born in terms of data integrity and AI integrity and how you trust what's actually happening. And once we start to trust those machine learned models, somebody's going to get inside of those and change the game on us, and we're going to need to make sure that there's a whole subset of cyber that we're working through to go play through it. But that's a great segue. You guys have done a fantastic job, I think, painting a broad picture of the state of technology and kind of what we're working on moving into the Navy's near-term needs or current needs when you go look at it. Great kind of perspective on what industry's doing, but what about the government? What are we seeing from examples of where the government is leaning forward, open architectures, training, adoption of new and evolving technologies, and maybe even more so, what more needs to be done, right? I think you've touched on it, but let's get real here and maybe let's talk specifics about it. So who wants to jump in on that one first? Dennis, got it.
Sure.
Go for it.
So I think a big one I'm seeing right now is the use of the ANSI VITA 49.2 standard right now. Government is pushing a lot of that in their RFPs, and I think that's great because it's really pushing forward hardware and software development to a common standard, and it's making it easier for everyone to be marching on the same plane for development, and it makes it easier for the developers to come up with solutions, and also for the third-party developers to develop their solutions so they can be integrated into the overall systems a lot easier.
Yeah, and I think I mentioned this at the beginning, but in some of these RFPs that you're seeing, if you had looked at an RFP 3, 4, 5 years ago, the term container wouldn't show up anywhere, right? You could search for it, it wouldn't show up. And now almost every one of these programs is saying container orchestration, open architectures. It's just been a very quick transformation. Cloud computing, all of those things are now sort of embedded in the way the government is looking at things going forward.
I would say the way that, as well, like everyone's talking about RFPs and programs, the research and collaboration elements of the Navy and Army and other elements too has gotten much stronger. Instead of standing up a whole program and then throwing a bunch of money into the pit, they go, hey, let's bring all of you industry people together and have you guys make some investments here before we define this whole program and throw a bunch of money into the pit.
Fair enough.
So.
Right. Yeah, so exactly kind of what Ramon was saying about containers. So yeah, several years ago they weren't asking for containers. We were using them though, right? They were just, something that I have observed, especially recently, I mean, Spectral prime example, is the government is getting much, much better about putting the parameters around what open architecture is. And I'll even go one step further where we're actually being evaluated. Actually, I just got done remotely supporting a no-kidding open architecture evaluation for a down-select contract, right? Years ago, that was basically unheard of. How do you evaluate for open architecture? Well, now, guess what? I'm going to show up with a third-party capability, and they're going to build to the API or the specs that you defined. Pick your standard, and if it doesn't work, it's not open, right? In the years past, being open was a check in the box, Or did you use OMS? Did you use VPX, right? By inspection, check, right? Now we can actually, test for these things.
Yeah, no, I think, I'm sorry, go ahead, Dennis.
I was going to say, and containers are fun. If you have worked in the software world, and have the scars to prove it, when you get to containers, it is fun. It's just a good way of doing things.
Well, and it can help solve a lot of problems that we've been dealing with for a long time. I mean, Ramon, we were kind of kicking it yesterday talking about the old, well, it works on my machine, which is kind of a standard software developer thing. Well, containers are, deploy anywhere, and they're incredibly repeatable. So we're slowly weaning out the, well, it works on my machine, kind of concept, and we can translate that to our customers when we deliver. Right?
Absolutely.
So the exact same thing that I'm using to build with or that I'm deploying, right? Here's my package that I'm going to deliver to you, right? And it's consistent.
Yep.
Yeah.
So DevSecOps is coming into its new right. Containers are fun. I like that. We got Ramon excited, so that's good.
That's great.
That's as excited as he gets, guys. Sorry, Dennis, go ahead.
Yeah, so one thing I was just going to add, so why are we doing this? Not obviously it's fun, but also build it once, but use it across multiple platforms. So you may build it for an NRO program, and the same container maybe could be used for a Navy program. So build it once, use it multiple times. Makes it easier for the OEM, makes it easier for our customers.
Yeah, so I was going to follow up. I do see a huge inflection point in how the government is leveraging software and building to a DevSecOps principle. Maybe we can talk a little bit about software factories, because I think that's the next new buzzword. And what are your thoughts on the various software factories across the government? Because to realize a build once, deploy anywhere type of construct, there has to be some underpinning or at least some forethought in terms of how we go about that. So maybe Ramon, I'm sure you have some thoughts on this. We'll start with you.
Sure. So, so adopting those DevSecOps principles and agile development methodologies and use of containers, those are all good, good things, and the government is trying to standardize in various ways how those things are developed. That DevSecOps, continuous integration, continuous deployment, CI/CD pipeline, and they have sprouted multiple of these environments, and over time you can imagine that there's going to be some consolidation there. But it's a good thing, and it's a good learning process for us as providers and the government as well. So I think it's just my opinion. I think it's a good thing for now, and it's part of the maturation process of those development methodologies.
No, fair enough. How about as a software insider, Dan, if you have any thoughts from Dell's perspective on software factories?
I would say probably, from our perspective, when you look at it from the OEM space, we're highly focused on supply chain, right? So how do we ensure and protect the, because everyone thinks of, like you guys talking about the containers and up above the application, there's a bunch of software that runs, you can commoditize your hardware as much as you want, still software running inside of those things. So from our perspective, we're continually working to try to figure out how to protect BIOS, how to protect firmware, ensure the resiliency of that. We were talking about the future. Some of the things that we're working on would be advanced telemetry to keep track of those elements and look at how you get to a self-healing perspective in the next 5 to 10 years, where you identify problems in the system and failover before you have a failure, right? Use your redundancy to help you. Where you get to the point where if you have something that's acting out of normal, then you segregate it, but you are able to keep the entire system running. And I think that plays into the supporting the ideals and structures of the software factories.
Good.
Yep.
Up.
So we're using the software factories. So shift left. I'm gonna talk about a couple of things here. So one, the shift left that we get to realize through using the software factories, right? Because of what we inherit. So Iron Bank is one of the software factories. It's a container registry, and what we pull out of that container registry are certified hardened containers. So what that means is we're starting with these packages that are already hardened, they already have ATOs, right? That's where we're starting from. So now, when we are bringing something new that we're going to test with, all we have to do is certify that delta, right? How much faster are we getting to our ATO, getting to our no-kidding secure solution, right? Because we only have to worry about this piece instead of the whole darn thing, right? The other thing that I'm going to talk about is, the software factories are really dominated by infrastructure as code. Okay? So we now get to inherit all of this infrastructure that's been stood up and done for us in a secure way, right? So we're now starting so much farther ahead than we were before, right? Because of really what the community is providing to us.
Yeah, no, I think one of the exciting things about this team, and I'm kind of wishing the Northrop guy was here, because I think you've done a fantastic job of pulling the classic OEM kind of construct of monolithic software into the future, and I think it wouldn't have happened if we didn't have this hybrid of a, kind of best in class across the board, anchored by Dell's commercial stuff, the CACI, the SNC, kind of subject matter expertise, and then getting to the high end, top side type of things of Northrop and working them in. And you guys have done a fantastic job with kind of navigating and all that and putting together something I think that's really better than the sum of its parts. So I applaud you for that.
Well, just to add on to that, because I do want to sing those praises too for companies like Northrop, Lockheed, and others, is the fact that where do we get all of our stuff from? Experience in industry. And those companies have been working with the federal government since before time.
Sure, of course.
So all of that experience has helped us understand how to shape and drive to support the mission.
Yeah,
so.
Good. Okay, so I've got some additional questions here, but I was going to throw it to the audience. Anybody has some thoughts or questions for this panel to tackle? I'm going to get a bunch of blank stares. And Mike's got one. What do you have, Mr. Loomis? Yeah, there's a mic back here.
Or you can yell.
We don't want to bring it further up because it would have to. You guys started the panel talking a lot about security and security of some technologies. I'm with Nokia. One of the technologies that's near and dear to us is 5G. And if I've looked at how some of these 3GPP systems have evolved, 5G is pretty secure. We're part of that same NIST program as that you mentioned earlier. If I think about the topic of the panel and the evolution of signals intelligence, as we make these systems more secure, there's a corresponding impact on our ability to maybe gather intelligence about some of those systems that are out there. I'm wondering if the panelists could comment on the ebb and flow of that, how does us building more inherent security into some of this technology impact the other mission, and how are we evolving in that push-pull in the life cycle?
Yeah, it's a great question. Anybody want to tackle that?
I'll
Go ahead.
Okay, I'll start. Right. So yeah, all right. Our adversaries, right, today, and thinking about the most complex threats of today and where they're likely going to be able to go tomorrow, right? We now need to be able to do ultra wideband signal processing, right? Tons of data, right? And things like advancements in system on chip, the next generation of FPGAs, right, are going to help us get there. Okay? Sorry, I'm kind of losing track here. You guys pick up for me. I think.
Do you want me to pick? You got it?
Well, Mike's coming back.
Go ahead. Go ahead.
Well, I'll wait for the answer, but I may have a follow-on question to your comment there, because
yeah. Go ahead. Yeah. So right. So larger instantaneous bandwidth. So more RF spectrum at once. Right. More sensitivity. Better DF, so we can kind of sort these things out. And I'm thinking about kind of a particular problem here, but yeah. So we need better receivers and better processing at the other end. Right?
And I will add, Matt, you actually said something earlier that's critical here too, and that was building security in at the beginning as part of the design makes it less cumbersome.
Right.
We have a huge challenge right now where everybody throws something out there and then go, we got to secure it to get to ATO.
Right.
So the stuff like the software factories you were talking about where you receive an element that's already secured, you just talked about it. It saves you tons of time and you don't have to then hurdle that gap. Right? So security at the beginning and making it less intrusive as part of the design requirement is going to be critical.
Get a follow-up?
Yeah, you commented about the need to process in ultra wideband and the impact that's going to have on the systems, and the need to drive some of that back into hardware. Another raging debate that occurs in our industry is network function virtualization. And when I get in a room and talk to some of our developers about that, they get kind of frustrated with it at times because putting these network functions onto general purpose processors doesn't necessarily simplify the system at all. And sometimes can create some inefficiencies in the system when you're trying to operate these things at a very, very high performance, like you kind of described. Towards the middle of the session, there was most of the talk was started to come in around how we were going to use a lot of these software-defined techniques to advance this. Do you see this coming back to where you need to drive it back into hardware at some point?
So I'll go back to software-defined, hardware-enabled, right? So we ride the hardware as it is available and as it's necessary, because changing hardware is expensive and it takes a lot of time, right? Now, of course, like we said, we're building into our systems now the ability to incorporate the next generation of hardware, but we want to solve that stuff with software first, right? So in the kind of solutions that we build that are, signal, right, RF signal processing focused, what we do, we've built an ecosystem where we pair that specialized processing, an FPGA or system on chip or GPU kind of processing with x86 processing, right? Because we need both. So we're passing the kind of functions and the kind of stuff that can be done into x86 processing there, right? But no kidding, there's stuff we still have to do and we're probably always going to have to do in that specialized kind of processing.
Yeah, and I think what you're talking or asking, Mike, it's the root problem underneath joint all domain command and control, because you've got an existing install base. You can't go necessarily switch out every piece of kit on an F-16. But you still got to talk to an F-35, and you got to take that forward to the hypersonic weapon that you might need or whatever, and you're dealing with this just kind of conflated set of hardware that goes back 30 years. So I think some of the things that we're seeing is stitching it together in software to allow the bridge across that. But there are, and maybe we should pivot to that after we get through the audience in terms of advances in technology too, because there's hardware focus that we have across the board as well. Good question.
Good morning, Jerry Burrows from S&C. So on any peer fight we may get into, we're going to see signals and threats on day one that we weren't expecting. Can you talk about how your architecture would enable a response to those threats and maybe how rapid that response might be?
Ramon, maybe you can take that on?
I didn't quite hear the
Yeah,
question.
I think the question
Can we
was... Get their question repeated?
Yeah, the question was, paraphrasing, when we get into tomorrow's fight, we may encounter things in the spectrum that we haven't seen before, right? So the counterinsurgency fight was pretty simple. You knew what was coming at you. You knew how to go defeat it. You had months or years to go build a solution. What happens when you're in the middle of the Pacific and you see a new signal coming at you? How do you go adapt?
Yeah, so that gets into how quickly you can analyze the new threat and develop a countermeasure against it, and how quickly you can deploy that on ships. And I'll go back to containers, right? They're much smaller packages that you can deploy over the air, assuming you have some level of connectivity to ships in a strike group, for example. And if it's an open architecture, you'll deploy them in a way that can be quickly integrated into the existing system, right? And it will roll out live, meaning you won't have to take the system down to add a new capability. It will be automatically integrated, with an over-the-air update into an existing system. So I think there are ways of doing that, and I think the Navy is going to lean forward on those types of requirements in the future.
And we'll also be fighting tomorrow's wars with tomorrow's technology, right? There's a lot of advancement going on. One of the areas that's really interesting to me is like quantum sensing, right? The capability to leverage that technology to identify and measure airflow and movements and environmental factors to pick up things that we wouldn't even dream of seeing on today's sensors. For early detection and response is going to be critical.
Yeah, well said.
Yeah.
Another question?
Yeah. Sorry.
There we go. You guys started off by talking about where things are heading in the next sort of 5 to 10 years. I'm sort of curious if you had thoughts about where those same relevant technologies are heading in like 15 or 20, a little further out kind of thing. You know, what should we be expecting with those systems that have to live on chips for the next 20, 30 years?
What's the 15-year out environment? Dan, you set the table on that, but new technologies are coming into play, certainly quantum. But what do we have on the drawing board, and what's 15 years out look like?
You know what keeps me up at night, and this is, it's a critical subject, but it's a boring subject. But again, I'm talking from the OEM perspective. It's what enables technology, which is supply chain. When everyone looks at what's going on in the world right now, everyone thinks that we need access to seaports, or we need access to to oil. No. We need access to rare metals, to build all of the chips, to support all of this infrastructure and build all this wonderful technology. Supply chain is going to be a critical issue now and is going to continue to grow in the next 15 to 20 years. There is a lot, talking about what is government doing to help. The government is doing large funding to start trying to figure out how to drive more chip manufacturing in the United States. But getting access to the elements to build that stuff is going to be critical. So supply chain to me is, I know it's not an exciting topic, but it should be.
Fair enough.
Right. And gosh, the things that I'm going to kind of tie a little bit back to the last question, kind of the things that we're doing with artificial intelligence and machine learning now, right? Where we're doing, so things like, signal recognition or, parameter characterization is happening. It's kind of happening in labs right now, so it's probably going to be reality in, five some years, right? Where that stuff is now happening better and faster in labs, and we're probably going to see that out in the field in years to come. And so where that sort of technique and a new way of doing it in the next 5 to 10, 20 years, holy cow. Right, and then as the computer science guy, that far out, start thinking about quantum computing, right, and what that's going to mean to cryptography, right, and gosh, so potentially our adversaries' ability to just break crypto when that sort of technology becomes readily available, right?
Yeah. No, well said.
Yeah.
Well said, sir.
Hey, thank you. My name's Angel Mesa. So as it relates to machine learning, just a good dovetail off what you were talking about, as it relates to the metrics utilized to measure machine learning performance, algorithmic performance, what are some of the areas that you're looking at to ensure and understand the left and right parameters of model performance? And then really, as it relates to adoption of AI for DoD, how are we being able to depict or portray that model performance so we understand how to employ a model and based off the operating environment associated to deployment?
Yeah. You want to take that one, Dennis?
Yeah, I think actually Ramon mentioned it a little bit earlier. I think one of the metrics is confidence, your confidence factors, right?
Right.
So if you're an operator and you pick up a signal and you're not sure if that signal it matches to your database, you'll be provided with a confidence level, whether or not of what level it actually matches. So confidence level is one of the metrics. I don't know, is there anything else?
Availability of data. The DoD, there's massive amounts of data, but actually sharing it and figuring out how you're talking about how to build a confidence factor in that to build your model effectively is a challenge right now because everything's compartmentalized. And there's lots of practical reasons it should be, right? Nobody's saying there isn't, but it does create a challenge there, right? Like how do you get this data and securely and effectively do the analysis to create the confidence factor to establish your models and yeah.
Yeah, and establishing boundaries around what this particular algorithm or system can do and what it can't do. How good is it at recognizing certain threat signals or certain threat environments, and where it drops off, and maybe the user is now involved in that decision making.
Yeah. No, I appreciate it. Just as a comeback, then I know each type of data is different, right? So there's not a cookie cutter solution, and that is the challenge, right?
Yeah.
But as you think about understanding the data performance and understanding that data, is there a way to portray, to establish a baseline, a building block approach to therefore build from, whether it's tabular, SAR, full motion video, what have you? Is there a way to focus and establish a benchmark? Because I think the key challenge is for AI adoption is understanding from the higher up leadership that grew up on acetate maps, and now we're doing everything on a visual in the cloud command post. How do we establish that benchmark to have a conversation that, hey, my model can do this and can do that, but it can't do this, but it works for this environment, let's go for it and make that decision. So that's what simplifying it from that aspect.
Certainly, I think one of the challenges facing us today, right, and to do it with the ethics and morals of the United States behind it, meaning that you've got absolute confidence that you have a person in the loop and you're working through it. I think that's the challenge we need to go work through. These guys are all working on digital twins and doing full up modeling and simulation with actual real physics. So the synthetic environments have gotten pretty sophisticated to where we can do a lot of that iteration, roll that into our training regimes, roll that into our mission preparation, and work through that as well. But I think you're hitting on it, sir. This is a big challenge for us to figure out, how to move into the next war. So thank you for that.
Thank you.
I think if we got one more real quick question, and we're coming to the end, so I'll take one more and then we'll wrap up. So please,
gentlemen. So the DoD published the AI training education strategy that outlines different levels of the AI workforce and developing an AI workforce. We largely have AI creators pushing stuff down to users, and there's not a lot addressed in between. The DoD is working on creating that technician level, middle ground workforce. So my question to the industry is, what is the industry doing to include access to AI models to manage and monitor these systems for their commanders on the ground at the tactical edge?
Yeah, it's a great question. I've got thoughts, but if you got something done, I think, well, I'll answer it then, and I'll take the last question from the podium and we'll go with that. But I think AI is going to be very much like the journey that the military's been on with cyber, right? And it took us literally probably 15 years to roll in a cyber mission and get the training regimes and get the ConOps and kind of work through all those. Probably going to be more difficult with AI because it's going to be one of those that are a little bit more nuanced and get into confidence intervals. But if you look at taking cyber effects to the DoD, it's sort of that same challenge of how do I trust this? Again, my analogy, you know what a missile's going to do, you know what a bullet's going to do. You've seen that for the last 10 years, 50 years, 1,000 years, depending on the kinetic effect that you're putting onto it. How do you trust something that happens in software? How do you do the battle damage assessment or the reverse? How do you trust the cognitive help you're getting from your AI? And how do you go work through it with a bunch of old soldiers, old sailors that are out there, and they learned in that kinetic fight. So I think it's probably going to be one of those generational things as the military moves through it, just like we did in cyber and some of the other, I'm going to say that's not the right word, but the fuzzy spaces that we're in, right? And that's a perfect segue to close out, because we intended, these guys all had hardware components to it, but Matt started us off with, it's really about software-defined everything, and taking a piece of hardware into, I don't care if it's a ship or putting it on a sailor or putting it on an airframe. That's a almost 10-year cycle to get through all of the confidence and the checks and balances that need to happen. We are today in a world where we can deploy software, and I've been on programs, we've done it in as few as a couple of hours since identification of need, to Ramon's a point on it, to where you've got the ATO in place, you have a development environment that's identical to your operations environment with the proper security overlay, really unpacking DevSecOps, you can get to speed. We are taking hardware that's out there today, so you take a radar, yesterday's radar was, you sent out a signal, you took that return. We're turning radars, because of software, into full spectrum sensors, taking SIGINT to the next level, working through all of that. I think cyber's coming into its own right. I could go on for another hour on cyber and where we're at, but I think we have put the infrastructure in place to pay attention to it. We've got cyber warriors embedded within every command structure. I am concerned at the vulnerability of our weapon systems out there, and I think there's more work to be done on that. And I know the NDAs of recent years are focusing on it. But when you got you look at the Air Force guys, I'll pick on them, a B-52 that's been flying since the 50s and is going to fly till the 50s. I mean, that's a crazy type of a moniker to go look at it. So software-defined everything. We talked through, Dennis and others, the cognitive load that we're putting on our sailors at this point and working through that. Again, making better use of technology, certainly in augmented and virtual reality, digital twins driving through all of that. Our friend from Dell, I think very aptly described the various leverage points that we're taking on the commercial side, and very much happy that the commercial industry is making a big push into technology development. And in my lifetime, and many of you in the audience, we've shifted from the DoD being the single biggest investor in technology to the software industry and the commercial industry to doing that. And I think we are coming into a new day in terms of how we leverage that and driving it, and I think this team is doing a fantastic play at that. And then Ramon's kind of coverage of open architectures and what'd you say? Containers are fun. We're going to go double down on that. But I think leveraging new software or modern software practices in that DevSecOps and taking it full circle to in a world of software-defined everything, I think is a pretty exciting time. And guys, I'm super proud of you. You did a fantastic job covering a bunch of difficult topics. We did cover a lot of topics, so thank you for that. Thanks everybody out here for listening. I do have those Navy jokes, so when you see me later in the hallway, we'll share those with you as well. But thanks again, everybody.